Well, hello there. Look, I know what you're thinking. You're thinking, I peaked too early. Last week was an amazing climax. We built a model that massively outperformed the frontier. It can't get better than that. Well, I've got news for you. It's gonna get better than that. We are actually gonna have the best week yet, and it's just getting started. So, this week, this week it's about reaching the pinnacle. It's about becoming a master of LLM engineering. And we're going to do it. We're going to have a blast. It's going to be epic. We are going to build a, multi-agent framework. We're going to build a solution that is going to be really, really awesome. And yeah, it's going to do something profound. And it's going to do it using everything that we've been building for the last 8 weeks. For today, though, we're going to be using Modal, the serverless platform for AI, so that we can deploy the same model that we built last week, our proprietary specialized LLM. We're going to be able to deploy it behind a serverless API on the cloud. And we're going to build the first agent of many, the first of the 7 agents that are going to be part of the solution that we are building this week to solve a juicy business problem. So, without further ado, let's get into week 8, the final week of mastering LLM engineering. And of course, it wouldn't be the start of a week without this picture. For the last time, let's look at the journey that you've been on. You started 7 weeks ago. You first we spent some time looking at frontier models, looking at asking questions, asking how many times the letter A appeared in this sentence, if you can remember that. In week 2, we built UIs, we experienced Gradio for the first time, we worked with agentization in a light way. It's going to get a lot heavier. And we played around with multimodality. In week 3, we went open source with Hugging Face, with tokenization, with models. In week 4, we built that amazing code generation tool that rewrote Python and C++. And in doing so, we explored how you select the right LLM to solve a business problem. In week 5, we tackled RAG using LangChain and built a question answering project. And maybe you built something bigger as well. In week 6 was when we started on training and we fine-tuned a frontier model. And week 7, of course, week 7 that we've just come from was when we beat that frontier model using QLoRa fine-tuning to make our own verticalized, specialized LLM. And I loved it, and I hope you did too. And so this week, week 8, the culmination of everything that's come before is when we have a finale. We master LLM engineering, and we're going to do it by focusing on agentic AI and building an agent platform. Let's talk more about that next time. And so it gives me great pleasure to introduce to you the project that I've lined up for you this week, and boy, is it a meaty one. Here it is, the capstone project of the course. I've called it The Price is Right. It's something which brings together what we've been doing to date. The idea is we're going to build, the challenge that's been set for us is to build a platform which can look for deals being published on the internet, subscribe to RSS feeds so it can spot deals that are being published. When it finds a potential deal, a promising looking deal, it will read it, it will interpret it, and it will then use a number of LLMs, including the proprietary one that we built last week, to make its own estimate of how much that's worth. And if it finds a good opportunity, it will then automatically send a text message or a push notification to you, to me, telling us that there is a deal that we should know about. And it will run autonomously all the time, just sitting around running in the background. And every so often, you will get a push notification to say there's a new deal that's been posted online where the model has decided that this price is a really great price because the item should cost a lot more. And I hope you agree. If we can pull that off, if we can build that platform, we've built something special. That is an advanced platform. It's something which brings together a lot of different bits of functionality. And it's something that hopefully, well, I will be proud of, and I hope you'll be proud of it too when it's built. There are going to be 7 agents. I already said it, but I'll say it again. 7 agents are going to collaborate. Not all of them are built on LLMs. Some of them are more sort of Python processes, but there's sort of 7 pieces to the puzzle that are collaborating. We will use GPT-4o or GPT-4o Mini to take information from RSS feeds and parse it and understand it and turn it into something which is a potential deal. We will use our frontier busting model that outperforms GPT-4o and Claude. We'll use it to estimate how much things are worth. But that's not all. We're going to use other models as well. We are going to build another RAG pipeline, another RAG-based model. But this time we're not going to use LangChain. We're going to roll our own, and it's going to be very, very easy. But it's going to use all 400,000 products that we had taken from the Amazon scrape before. We're going to put all of them in a mega Chroma database and use that to add context as part of our RAG pipeline to a frontier model. And you can start wondering right now, maybe you already thought of this, maybe you're already wondering whether or not a frontier model that's armed with similar prices of similar products, whether that is going to outperform the model that we fine-tuned last week. You'll find out. We'll see. But we're going to have both models working together to try and get the best possible price, and another model as well, as all will be revealed. So it's going to be a huge week. The most important point, of course, was this Capstone project is designed to bring it all together in a very satisfying way, in a way that's going to feel tangible and real. But the real point is that this gives you a chance to revise on everything that we've learned, and also just build expertise, build experience, have some real hands-on work at making production caliber models. And that's really the main point of this. We're doing it in a fun context, something that's going to actually send you push notifications when there's a useful product. But it's going to be about learning and solidifying the learning that we've done over the course of the last 7 weeks. But let me just tell you for a moment the architecture of our agent platform. We're going to have a user interface. Of course, it's going to be built in Gradio. It's going to be using an agent framework that we'll write, which will just be a simple kind of environment, which will have memory so that the agents can know what they've recommended in the past, and it will support things like logging so we can understand what's going on in our framework. There will be an agent responsible for planning. It's going to be coordinating activities across the other agents. And then we'll have these agents. We'll have a scanner agent that is going to identify promising deals by looking at RSS feeds. We're going to have something I'm calling the ensemble agent, which is something, there is a technical term, ensemble, when you bring together multiple models. This agent is going to be responsible for bringing together different estimating models that will estimate the price of products. And we will have a messaging agent that will send us push notifications. Now, this is just the high-level architecture because there are more agents than this, because, of course, that ensemble agent is itself going to collaborate with 3 other agents that will be our 3 estimating agents. But I'm not showing them on this diagram because that would be too cluttered, but I will do, I'm sure, in the future when we get there. So this is the high-level architecture to give you a sense of what we're going to build, and for today, we're going to focus on just one of these, and we're not going to look much at this architecture. We're just going to be talking about taking the model we built last time and putting it up on the internet using this wonderful service called Modal. Just before we talk about Modal, one more thing. I wanted to mention that as we're moving now towards writing more serious code, Jupyter Lab is a wonderful platform for being iterative and experimental and quickly turning out different solutions. But as we move along the path from R&D into something which is ready to be productionized, there are some aspects of the coding that will be changing. For a start, I'm going to start to have type hints in some of the code. Maybe something that you're super familiar with already. If not, I'll explain it, and you'll see why. And it's something which is a good best practice when building this kind of production caliber code. Also going to be writing some more comments. It's something that when you've got a nice Jupyter notebook and you've got like lots of time to put text and stuff and explain it, maybe you don't need quite the same kind of commenting approach. But now at least at the method, at the function level, we'll put comments in there. And logging is a good thing to do as well, and we will do that. Now, there's one other thing which is a very good best practice, which is to write unit tests. It's very important, of course, to write good unit tests for code that's going to production. And I'm not going to be doing that because I'm a cowboy. Yeah, I certainly should do that. But what I will say is that it's a great exercise should you wish to go in and write unit tests behind some of the code that we are productionizing. That will be wonderful. I'd hugely appreciate it. And if you then wanted, of course, to do a git push, I will merge it in with delight and will give you, of course, full attribution and credit for writing the unit tests, which is something that certainly I should be doing. And it's very much a good best practice. Okay. That brings me to introducing Modal, which is the platform that we're going to be using today. Modal, a platform which allows us to run code remotely on a server, and you only pay for the time that you use. It's a very powerful platform. It's become heavily used in the AI world for deploying production models, but it can also be used just for many different purposes, just for CPU usage to deploy any function onto the cloud, as we will see. So without further ado, in the next video, we're going to go to Modal and give it a try. I'll see you there. And so here we are at the homepage for Modal at modal.com, spelt M-O-D-A-L, not model, which is confusing. So what is Modal? So Modal is a service that allows you to take code, and it really can be any code, and deploy it and run it remotely so that you can run it from, say, Jupyter Lab or just from some Python code running on your box. And what makes Modal so powerful is that it makes it incredibly easy just to wrap up a function and have that be called so that it's almost transparent to you. It almost feels like you're calling a function that's running locally on your box. And in fact, it's being called out to the cloud and the answer is coming back. So it gives you such transparency and it allows you to work almost seamlessly between your box and the cloud. Now, a lot of the way it works is that it also allows you to package your code into an API and have it running in such a way that people can use like REST APIs to call your code. We're not going to do that because we're working in Python and this is all Python code. And it's even easier if all you need to do is call Python functions remotely on the cloud. And whilst it is, as I say, mostly used by AI teams and for AI, as it's showing right here, AI and data and machine learning, it can also just be used for really anything that you can write in Python, you can run on the cloud. And so it's very versatile indeed. One other thing I'll mention that makes it very powerful is that you only pay for the compute time that you use, unlike services like AWS or something. It's one of these things where it will spin up a server on demand, and if it's not used for a while, it will pause that server, and you'll only pay for the CPU minutes that your server is running for. So. Also, the good news is that if you sign up for a new account, you get $30 of free credit. And we won't even come close to spending that $30 in this class. So you don't need to be concerned about charges. This will be a freebie. Should you get addicted and you end up using Modal for all sorts of purposes, then I can't be held accountable for that. But you will get, hopefully, your $30 of free credits, unless they take that away. But even if they do that, as you will see, it's not exactly an expensive proposition. So when you go to modal.com, you'll need to sign up the first time and create an account, assuming you don't have one already. And once you've done that, you'll end up in a dashboard. And this is my dashboard right here. And you can see here my live usage in the time that I've been using Modal to prepare for this class that has been going on for a while and running it a number of times. I've managed to rack up a $5 bill out of my $30 of free credit. So I've barely scratched the surface. And even if I hadn't got the free credit, it would be a $5 price tag for everything I'd done. So as I say, it's cheap. Here I'm looking at apps, which are the programs that I've deployed. And of course, we're going to be building a Pricer service later. If I go into this, you'll see that you can see all the different deployments that I've made of this service. And this will all make more sense when we actually do it. And you can see it's been called apparently 116 times. You can see various other things about it. But really, that's it. One of the nice things about Modal is that whilst one does have tokens and keys and all the rest of it, you don't need to go in and set it up and write it down, because it's going to do it all for you, and it's going to be very easy. All you have to do is sign up with an account, and then everything else will follow naturally. Okay, so with that, once you've signed up with your Modal account, do some clicking around. You can always read there's really nice docs. There's this guide. You don't need to read this because we'll be doing some of this, but it gives you a real sense. There's a Hello World program as well, but we'll be doing that ourselves. As you will see, we'll get to that in the next video. I will see you then. Well, welcome back to Jupyter Lab for what will be an epic finale to our time in this platform. And it's going to be such a great conclusion to the last 7 weeks. The first thing you'll notice is that there's quite a lot going on in the week 8 folder. There are a lot of files here, which reflects the fact that we've got a lot to get through, a lot of work to be done to solve this big problem. It means I'm going to be moving at a faster pace than usual as we go through this code, but that's okay, because at this point you are proficient, you're well on your way to mastering LLM engineering, and you no longer need me to belabor the point about lists of dicts of assistants and users and things like that. It's now something that is very much old news. Yeah, it's amazing to think I was explaining what tokens were only a matter of weeks ago, and now that you're ready for a big, full-on agentic AI solution. A quick admin point before we get started. I've made some changes to the packages. I've added some more packages that are dependencies on this environment in order to really make this a very, very juicy problem. And that just means you might need, if you pulled the code sometime before, like late September, you might need to pull the code again and update your packages to have anything new that I've added. And that's very easy to do. All you have to do, of course, is go to the project home directory, so LLM engineering. And if you're on a PC, then you need to be in an Anaconda prompt. And then you do a git pull to get the latest code. And then you run conda env update. You specify the file as environment.yaml, and the -- prune tells it to remove any packages that are no longer in the list. I don't think I have removed anything, but anyways, I think this is always a sensible one-liner. Good to have that to hand to update your environment with a new environment.yaml file. Okay, so here we go. Let's talk about Modal. So as we get into today's class, there only is one import to begin with, and it is to import Modal. There we go. Now, if you have not set up your tokens, which you will not have done, then you need to run a command line thing called modal setup. And the way you can run that is you just uncomment this line and you run that statement right there. Now, I'm not going to do it because I've already done it and my environment's set up. But when you do, it's going to pop up with a browser window and have you authorize Modal. And then Modal will set your environment variables for you. And I think that's really great. All of the challenges that people have had with tokens, particularly with OpenAI, this is a very different experience. It's really streamlined. So good for Modal. They seem to have really figured out the way to set tokens. If for any reason that doesn't work for you, then if you go into the Modal platform, you can actually find your tokens in there in much the same way as you can for things like OpenAI, and then you can manually set it. But hopefully this would just work. It certainly did for me, and by all accounts, that's how it works for people generally. All right, so now, in the next line, I'm going to import some things from a package called Hello, which is just one I've written over here. And I'm going to take you over to that right now to show you what it looks like. So this is just a piece of Python. It's just some Python code. And I'm going to tell you what it does. So we import Modal. And from Modal, we import a few things: app for applications, volume, and image. And actually, now that I look at it, I see that I don't actually end up using volume, so I don't think that is needed. Keep this simple is better. So this is what you do. You begin with some setup. You tell Modal what kind of infrastructure you need. And this is an example. Modal talks about this a bit in their docs. But this is a type of infrastructure as code. You can use code to describe what kind of box you want. So if you're thinking, when we were in Google Colab, we had to pick various drop downs and choose what kind of VM, what runtime we wanted from Google Colab. Well, here you just get to choose what you want by specifying it in code. So we say that we want an image, which we want it to be the Debian operating system. We want to pip install the requests package, that very, very common standard package for doing URL web work. And we specify a GPU, actually, which again is also not used in this example. Sorry, that makes it a bit simpler. We're not going to use a GPU for this example because we're keeping it very simple indeed. I have got a method called hello. It's a very simple, it's a function, hello, that returns a string. And what it does is it imports requests. It goes to a website called ipinfo.io, which is a useful one to know. It's just one of these utilities that will return a JSON object which describes where you are, the IP address of what just called it. And so then I take that JSON, I pull out the city, the region, and the country, and I say hello from city, region, country. And it's just based on your IP address. So it's just going to say hello from and wherever you are, or at least wherever your ISP is serving you from. So for me, it's going to be somewhere fairly close to New York, but may not be in New York. So that's a pretty simple function. The only potential interesting thing about it is this decorator at the top here, which is a Gradio decorator, where we've decorated it with app, which is this thing here, this modal app hello, .function, and then we're passing in this image, and that image refers to a Debian image which has requests installed. And just by decorating it with that, we're saying that's the kind of box that we want to be able to run this on, should we wish to. That's all there is to it. So you could put that to one side. You could imagine that this was just part of an existing piece of code you had to do something, and now you've just decorated it with something to say that you want to be able to run it, should you wish to, using a Debian operating system with requests installed. So that is all that's in this hello.py. Super simple. We go back to day one the Jupyter Notebook. So I'm now going to import that. And so now what I can do is I can call my hello. I can take my hello function that I've imported here, and I can call it by saying hello.local. And what that means is I want to run that function that I've just defined, that we just looked at, this function here, and I just want to run it on my local box. I want to run it in this Jupyter Notebook. Let's see what we get. So it's running right now, and it says hello from Seaport, New York, US. That is where my ISP is, I guess. Let's try that again. Yeah, that seems pretty consistent. So that's running locally. Now look at this one here. It's exactly the same thing. I've just changed local to remote. That's the only thing I've changed. Let's see what happens. It's taking a little bit longer. And then hello from Ashburn, Virginia, US. It's running in a completely different state. So I'm sure you were expecting that. You get the idea. And sometimes it's different, by the way. I've seen it pop up all over the place. So simply by calling remote instead of local, you can call this function, the same piece of code, the same piece of Python code, and it's been deployed to a server, and it's running on that server instead. So I think that's pretty magical. It's magical because it's so simple, and it's just allowed us to deploy some code. And now we've got a slightly more involved package called LLAMA. And this is where things like GPUs start to appear. You can see I paired this back to the hello example, which is why there was some traces of what this was. So I start by calling my app Llama. Now I'm going to again have a Debian image, but this time I'm going to install Torch, Transformers, Bits and Bytes, and Accelerate, all packages that you know well at this point. I am also getting my Hugging Face token from my Modal secrets, and that is something I should have shown you before. I will show you in a second how you set that up in Modal, how you get to secrets and you can set your Hugging Face token in there. And once you've done that, you can read it like this. And I'm specifying that I want a T4 GPU, which of course is the very cheap basic one. And I've got a constant here. And now I have this generate function. And it takes a prompt, which is a string, and it returns a string. And this is an example of the type hints. If you're not familiar with them, it's something that I'll be doing this time round in various places, and it will, I think, become clear after a bit. So again, I decorate this function with, I pass in the image, I tell it my secrets, and I say I want a T4 GPU, all configuring my server using code. And now this is just a function as if I were writing something to run locally. Now I couldn't possibly run this locally because my box has nothing like the horsepower to be able to run a Llama model like this locally. There are ways you can do it with things like Llama CPP if you're familiar with that, but I wouldn't be able to do it like it's written here. And if I did, it would be very, very slow. And so I want to do it on a box which has a T4 GPU, and this is how I'll be able to do it. And so this code should all look very familiar to you. This is the quant config that you know well, that specifies the 4-bit quantization that we'll have for Llama. We are going to load the tokenizer, this boilerplate stuff you know well. We are going to load our model, and then this you should also recognize. We encode the prompt into tokens as our input. We set this attention mask to avoid getting that warning. And then we do model.generate. We pass in our inputs. We say we only need 5 new tokens, and we want to just one response. We will take that one response, we will decode it, and we will return it. It's as simple as that. Now, with that, let's start that and let's run it. So, stuff is happening. So, first of all, what have I actually run? So I've called the remote function, and what I passed in, the prompt that I passed in to a Llama model is, life is a mystery. Everyone must stand alone. I hear. Now, hopefully most people know what comes next from that. Otherwise, I'm going to feel very old. But this, of course, would be straight from the opening to Like a Prayer by Madonna. And I hear you call my name would be what comes next. And it's almost unbearable not to say that. And now I'm going to hear that song in my head for the rest of the day. Yeah, and sorry if I put that now in your mind forever too, but such a catchy song. Anyway, it's what we're seeing now is what's going on that box. And we can also flip over to Modal itself. Let's see, let me refresh this screen. So it's not a deployed app. Ephemeral apps, that's what it is. Give me a second to find that. So this is it running right now, running as an ephemeral app. Generate started 2 minutes ago, and we can click into it, and we can see that its status is running. Let's see what else we can get. This is the containers. It's live. We can look at the memory, the CPU cores. And we can see it's a T4 GPU, just as we specified. And we can also look at the, we can see that hello.py is also on this box that we just ran, and llama.py is sitting there, the Python script that we just wrote. So here we go. While we're here, I'm just going to point out that right at the top here is secrets. And secrets is, of course, where you go to set the secrets, the Hugging Face token. So you will need to do that. I'm not going to click on that now to avoid revealing my Hugging Face token secret, but that's where you would go so that you can then use your Hugging Face token in the code that's deployed in your ephemeral service here. So it's still running, and I think at this point I will hold to this video, and when I come back, oh, it's already just said it succeeded. And I did just get a message saying that it had finished as well. And let's see, yes, back here. Let's see what we get. I hear you call my name. So Llama, even the 4-bit quantized version of Llama also couldn't resist completing the Madonna song as well. So we have just successfully run this piece of code using this ephemeral service on Modal to run a quantized Llama model, a Llama 3.1 model to complete a prompt. All right, when we come back, we're going to go through, and it's going to be time for us to deploy our model and actually see how we do that and how we put an API around the proprietary model that we built last time. I will see you in a minute. So what you just saw was an ephemeral app, as it's called, which means just a temporary app that you're just using for testing before finally picking an app to deploy. And we're going to stay with ephemeral apps for a little bit longer because we're now going to take our proprietary model that we built last time and deploy that as an ephemeral app before we do it for reals. So in order to do that, let me show you this other file here called pricerephemeral.py, which is a Python module, which is going to have some similarities with what you just saw, but with one key difference, which is instead of using Llama 3.1, we're going to use our own fine-tuned model using very similar code to the code that we used in the collab when we were running our model in inference, when we were testing it and had the wonderful moment when it did so well. So in this Python module, then we begin as before by importing Modal. And again, I will remove volume. At one point I was going to use that, but I ended up not. So you set up, you say that you have an app. It's called Pricer. That's going to be the name of the app. You saw Pricer. You saw my deployed version of Pricer before. And now we create an image and we install the same packages. But wait, there's a new package. You'll remember PEFT, the parameter efficient fine-tuning package that we need in order to be able to load in our fine-tuned weights and our secrets. Hopefully you found your way to adding them in, and you should put them under HF secret, or if you put it on something else, then obviously change the name here. That's the name of the category of secrets, and then within that you have to have exactly the usual Hugging HF underscore token for the token itself. See if that's actually in the code somewhere. I don't think it is. Anyways, so if that, hopefully that makes sense. We then specify we want a T4 GPU. We specify the base model, of course, Llama 3.1 8 billion. The project name, this is because we're going to be pulling it from the Hugging Face hub. So this is my Hugging Face username. If you want to use my trained version, then keep my name there. If you want to use your version because you fine-tuned a version and maybe you made it even better, maybe you've done some hyperparameter optimization and you have beaten me, in which case you should definitely use your one instead. But this is mine, and if you use mine, then you should use that run name, and this revision number, which you'll remember was the epoch where I'd got the best results before it started to overfit. And so this ends up with the fine-tuned model name. And so we have a simple function price, and it's a function which is almost identical to the function that we had in the Google Colab. It's just we've got it sitting here on my local box, and we're going to decorate it with this decorator that says that we want to run it in this image with these secrets and this GPU. But this is all the same stuff. We do some imports. We note the question and the prefix. The prompt is going to be how much does this cost to the nearest dollar, then the description of the product, and then price is dollars, and then it's going to be almost unbearable for the model not to respond with what the price is. And then here we do the quantization, we load the model as before, and this line, hopefully you remember this. This is where we load in the LoRa fine-tuned model. We provide a base model, we provide the name of the fine-tuned model, and in this case the revision number. You can leave that off if you're just taking the final save. You don't need to take an interim point the way that I am. This is for reproducibility, so that it's the random seed is set, so you get the same numbers each time. We tokenize. We then make the call .generate to our fine-tuned model, and we decode. And then finally, hopefully you also recognize this code. This is a bit of janky code that strips out the number, the floating point number from within the text that comes back, just in case there's an errant $sign or something like that, and make sure we get whatever number we can, and returns that number. And that's all there is to it. It's code that should be pretty familiar to you at this point. So now we go back here. I did already run it because, as before, because it needs to warm up. It takes a couple of minutes, so it would be agonizing if we had to wait each time, but I already ran it. This is, of course, what I ran. You say you don't need to actually have this with modal.enable output, but if you don't do that, there's lots of other stuff prints. So this is a way to make it so that it's nice and neat. But you do need to have with app.run, and then I just say result is price.remote. And then what I'm asking for is to price a particular object that just looking around for something that I could ask it to price. And the object that I've asked it to price is the very microphone that I'm talking into right here. So I just typed it in there. I remember how much it cost. And so why not? Let's see how it does estimating that. So I ran it. It did take a couple of minutes. Now it takes a couple of minutes because it has to warm up that box and populate things, because it has to do everything you can imagine you'd have to do if you ran this in Colab. It has to download from the Hugging Face hub and then load it into memory. It also has to pip install all of those packages. So there's a lot that has to happen, which is why it takes a bit of time. And it did all this stuff. And at the end, it completed and it returned the number $133. And I think that is round about what this costs. So, yep, it's I think that's pretty much spot on. So maybe it was who knows, it could have been in the training data set, but certainly a nice result. So hopefully you're doing this too. You're trying this. You'll have to wait those 3 minutes. You'll be able to go onto Modal while you're doing it, and you'll be able to go to ephemeral apps. It's no longer running, but while it was running, it will have been here, and you'll be able to watch it and see it doing its thing, and then get a satisfactory result. Okay, but now we've done that, it's time to make the transition from these ephemeral apps, which is just ways of running functions remotely. Now we're going to have deployed apps, which is when we tell Modal that we've got some functionality and we want to have it be permanently sitting on Modal. We'll still only pay for it when we actually run it, but we do want to give it a sort of a name and a proper place where we can quickly get back to it if we need to. And the way you do it is on the command line, you type modal deploy and then the name of the app that you want to deploy. And it's important to note that this is the moment that we are taking some code, some model that we have built as data scientists, and we are deploying it in a way that can be used for production purposes. It's going to have a Python API behind it. People will be able to call it from Python and be able to invoke our API. And this is an example of productionizing something that we've built originally in Jupyter Lab. It can also, Modal also allows you to build REST endpoints very easily so that it doesn't need to be called by Python. It can just be called from any HTTP query. We're not going to cover that in this class because everything we're doing is in Python, so we might as well just call it from Python. But it's very easy to do, and the docs are super clear about it. So one thing I glossed over a moment ago, you may know this already, Jupyter has this great feature that if you want to, you can run something in terminal just by doing an exclamation mark and then the name of the command you want to run. You can also actually open up a terminal window by pressing the plus button there and create a terminal. But this is even easier because you can do it right in the prompt here, which I did above. And the command, again, is modal deploy and then the package name. So it's price as service. So let's go and have a look at this package called price as service. Let me quickly tell you what I've got here. So it's remarkably similar. You can see that basically we have the constants, we define the function, and it's basically the same thing. But this is going to be enough to deploy our code as a service, as a proper deployed service, rather than the ephemeral version of the processor we had before. But yeah, it is the same thing. It's the identical code, just packaged differently. And again, with this volume that's not required. So on running that, if we go back to the day one notebook, you'll see that it deployed it as price as service. It gives me a little URL at the end of it. And then once it's done that, if I go now back here and I go to deployed apps, you'll see that Pricer is running there, sitting on a T4 GPU box, just as we specified. If we come back here, the way that you call a deployed app is different and actually simpler than the ephemeral app. You don't need that scaffolding you saw a moment ago. Instead, you just say modal.function.lookup, and then you give the name of the service and then the name of the function. Simple as that. Modal.function.lookup, the service and the function. And so once you've run that, you can then say pricer.remote and make the remote call, and we get back the same number, 133. And that's all there is to it. We've just deployed an app with our proprietary model to the cloud, and we've called it, and it's run on the cloud. Now, there is a nicer way of doing this, a fancier way of doing this. When we build it this way, every time that it goes to sleep and needs to be warmed back up again, which, by the way, is quite quickly, like after a minute or two, it goes to sleep. So every time you call it, you're wasting all that extra time. Basically, every time it has to rebuild an image and do the imports and load the model and so on. Sorry, I jumped to the version where it doesn't have to do that. Here we go. This is the bad version where it has to do all of that. So I've made a second version of it, price as service 2.py, this module. And this one is done a bit in a smarter way. It's done using a class, and it's done in a way that allows you to pre-build some aspects of initialization, so you don't need to do it every time. So when you define a class like this, you have the ability to use this decorator modal.build and write a function that will populate your box the first time that it's built. And in this case, I download from Hugging Face the model and I put it in the cache. And I'm not going to walk through this in detail because I'm going to leave that as an exercise for you in the interest of time, but it's perfectly self-explanatory. This code will load the files from Hugging Face and put it in Hugging Face's cache. And then you can have this decorator modal.enter, and this is when the function actually gets called, and this is where it's going to set things up by setting up a tokenizer and setting up a base model that will be loaded once so it can be used repeatedly if this is called before it goes to sleep. And this is the method itself, price. This is now the same as before. But the code to load the model into memory has been pulled out into this one here, into modal, into setup under the decorator modal.enter. And so as a result of all of this, if I haven't lost you yet with this, when I go back to day one, the key point, I then do a modal deploy of price of service 2. So price of service 2 gets deployed. And when I've done that, I can then use this code, slightly different. You remember, this is what we did last time. We did modal.function.lookup. Now we do modal.class, which annoyingly is spelled CLS. Class is probably something that is already used, so they couldn't use that. So modal.class.lookup, and then pricer service and pricer, now with a capital P, pricer, it's the class. So this will find the class that we've just deployed. You can instantiate that class. So I say pricer is an instance of pricer, and then I can call pricer.price.remote. And when I do that, I get back that answer again. And when I ran this before, it ran super fast because it was already in memory, but now it's probably swapped out already. So yeah, I won't do it now to avoid holding us up, because we'll press on to the final example, which I will run. I'm going to kick it off now so that I can talk while it's doing its thing. We'll let it run. So I have packaged this into a nice, useful class called specialist agent. Which is our first agent that we're going to look at. And it is something which is going to look up our pricer running on Modal and call our pricer. And it's something which just takes a single function, a single method, price, and you can pass in what you want it to price. Let's go and look. It's in agents. Now you get your first preview look at all of the different agents that we're going to be playing with this week. And we're going to go in and have a look at this particular agent. It's called specialist agent because it's using our special model. So this is our Python module for our specialist agent. And as I promised, you see that I've written comments and that there's some type hints going on. So this class is a very simple class. It's an agent that runs our fine-tuned LLM remotely on Modal. It sets a name, it gives itself a name and a color. And the reason for that, you'll find out later, is that we're going to have our agents log, so we'll be able to see what they're all doing. And the specialist agent is going to take the color red, so you'll be able to see when it's thinking and doing things and so on. So I initialize in the initialization, in the constructor method here. I log that it's getting started, and I do this modal.plus.lookup, and I look up the pricer service and the pricer. And this is the thing that we just deployed a moment ago. So we look that up and we instantiate it, and then we log that we are ready for business. And the price call itself does exactly what we just looked at. We do pricer.price.remote. It's just like when we did the hello.remote. We're taking a function, we're calling a remote, which means it's going to run on the cloud. It's almost transparent to us. It's like we're calling it directly here in Python, but it's actually going to run on the cloud, on the T4 box that we specified. We pass in the description, we log the fact that it's completed, and we return the result. So hopefully I've yabbered away for long enough that when we turn back to day one, it's going to have finished. And it hasn't finished. Well, then I can also fill in the time by flipping over here, and we can take a look at it doing its thing. So here, now, before you remember I got lost looking for ephemeral apps, we are now correctly on deployed apps because we're looking at our pricer service, our pricer, which is a deployed app. We can go into this and have a look at it. Oh, it's now saying succeeded. Let's go back and have a look. It has indeed succeeded. There we go. It succeeded and it returned the right number, 133. And if we run it again right away without delay, see how quick it is? That's how quick it normally is when it's already warm. That's going out to the cloud. Let's quickly come up with something different. Let's go for an iPhone SE second edition. Let's see how much an iPhone. There we go, $299 apparently. So I'm delighted that we got to see that. And iPad Pro second generation, $299 again. It seems must be a popular price. So you get a good sense once it's warmed up. Once you've populated the model, you can call it very quickly and you'll get back a quick response. And again, we're calling our agent. And what our agent is doing is our agent over here is simply, it's done this already. It's already got the class. It's already instantiated it. And that class is already loaded in the files from Hugging Face, and it's warm and ready for business. And then when we call this method, it doesn't need to load in the files again. It's got it already. All it needs to do is inference. And that's why it's so quick. And that's the trick. That's how you build an API to a model that's running in the cloud, serverless, and how you make sure that you've cached the model weights in memory so that it's ready for action. So I know we went through it very fast, but now you have to go back and do this again yourself, make sure that you can make it work and that it looks good on Modal, and I will see you in the next video to wrap up. Now, look, I know that I went through that very fast, that maybe you're still blinking at the end of that, but that's because the point is that you should go back now and do this yourself and see it. And as you run that code and you see what's going on in the Modal screens, I think it's going to make complete sense. In case that you have any problems with that Hugging Face token, I'm going to put better instructions in the Jupyter Lab so that's very clear for you. And yeah, I think you'll find that it will be fairly straightforward, and you'll see how that works and why it's working so fast. There's the first time you run it for a while, there's several minutes for it to warm up, but then subsequently, because we've cached the model weights and we've loaded it into memory, it should run quickly as it did just then. So with that, you have now learned how to take a model and how to deploy it to production so that people can call it just with Python code for production purposes within applications outside something like a Jupyter Lab. And hopefully you're now beginning to appreciate that we do have a big week, and it is an epic project and there's a lot to be done. In fact, the next day's worth of activities is the biggest of the lot. There's an awful lot happening. But just to remind yourself for today that this was about deploying models in production using Modal, the serverless platform. In some ways, it's similar to when we deployed a model, or I deployed a model to the Hugging Face using Hugging Face endpoints. But you can see the extra functionality that you get with this, the ability to configure infrastructure with code, and the way that the pricing works. It's a very, very powerful platform. Next time, you'll be able to build an advanced RAG solution. You're saying, you already got RAG. We've done RAG. We know RAG. Well, you're going to know it even more next time. We're going to use RAG. We're going to do it directly without LangChain. We're pros now. We don't need LangChain. We can do it ourselves. We're going to look things up in a Chroma data store and use it to give context to a model, but it's going to be an enormous, great data store. And we're going to build something called an ensemble model, which is a kind of model that combines the best of multiple models. And we're going to be able to deliver production-ready code that will span multiple models. So it's going to be about really strengthening your skill set, building expertise as you make the transition from being knowledgeable in LLM engineering to being a master of LLM engineering. And with that, I'll see you next time.